Alright, non-resident training course, September 1998, Navy Electronic Training Series, Module 15, Principles of Synchros, Servos, and Gyros. Distribution statement approved for public release, distribution unlimited. Chapter 2, Servos. Learning objective. Upon completion of this chapter, you will be able to define the term of the servo system, the terms associated with the servo system, including open loop with a closed loop control system, identified with the schematic with the block diagrams and various servo circuits to give a short explanation of the components, the characteristics of each of the circuit, the characteristic of the trace, of the flow, of the data, of the component, of the typical servo system, the inputs to the outputs, and cause to effect. Servo mechanisms called the servo system, the count lift, the application, the operation, electronic equipment that working with the radar antenna, the directive of the computing device, the shifting communications aircraft, with many other equipment, and this is often necessary to operate with mechanical load that is remote from the source of the control to obtain the smooth, continuous, accurate operation of the load that normally best controlled by the synchros. As already with the know, the big problem that is in the synchros that they're not powerful enough to do any with a greater amount of work. There was servos come into use. Servo system used as a weak control signal for the move of the large load with the desired position for the great accuracy for the keywords for the definition or move with the greater accuracy. Servos may be found in the chest with the buried applicate for the move of the rotor, elevated with the model plane with the airplane with the radio control flight with the control driving the plane with the rudders of the nuclear submarine. Servos and powerful. They can move the heavy load with the remote control with the greater precision by the synchro device for the take of many forms of the servo system. They can either be electromechanical, electrical, hydraulic, pneumatic, whatever the forms of the relative, the relatively weak signal with the rapid of the desired movement over the load with the generator with the control but amplified that is the servo motor with the work of the moving heavy load. But the category of the control system, with the group of the component, with the links together to perform the specific purpose, generally with the control system, large power gain between input and output of the components used, and the system complexity with the system are directed with the requirements of the system. Application of the closed control system are broadly classified in these are closed loop and open loop. With the closed loop, the control system are the type of the most commonly used with the Navy because they respond with the more load with the controller quick with the greater accuracy of the open loop system. For the reason the quick response with the greater accuracy of the automatic feedback system, they perform for the input with the desired amount of desired movement that has been taken with the police upon with the receipt with the feedback information with the system stop with the motor, the motion of the load ceases until another movement is ordered into input with similar to this system with the control for the heat and many with the home with the thermostat and input call for the heat with the furnace output produced for the heat with the distribute for the sum of the heat and the feedback with the thermostat when this feedback rate with the temperature of the room with the thermostat setting with the thermostat respond with the shutting of the system down with the until the heat is heat again with the required with such a system feedback with the path with the input with the back and the input into the input to the output back to the input form, which is called the closed loop. The term you will hear at the end, the often discussion control system, because of the closed loop control system is automatic nature. They are further classified as the function of they serve the controlling the position, the velocity, with the acceleration load being driven. An open control system with control directly only with the input signal without with the benefit of the feedback with the basic unit system with the amplifier with the motor with the amplifier receive the low level of the input signal with the amplifier, but it is enough to drive the mode with the perform the desired job. The open loop control systems are not commonly used with a closed loop control system because they are less accurate. The open loop control system, as we stated previously, the open loop control system is controlled directly only with the input of the basic unit of the type of the only amplifier with the motor with the amplifier receive the low level of the input signal with the amplifier but enough to drive the mode to perform the desired job of the open loop control system as shown with the basic block of the diagram. Form figure 2.1 with the system with its input signal is fed by the amplifier. The output amplifier is proportional to the amplitude of the input signal with the phase of the AC system. The polarity of the DC system of the input signal will determine the direction of the motor shaft that will turn after the application of the input signal is fed into the motor with its move of the output shaft of the load with the direction of the corresponding with the input signal. The motor will not stop driving the output shaft until the input signal is reduced to zero removed. This system usually requires an operator with a control speed with the direction of the movement and the output with the varying input, but the operator control could be controlling input by either mechanical or electrical linkage. 2.1 Open loop control system became basic block diagram. Input signal, amplifier, amplified signal, motor, output shaft of the load. The closed loop control system. The closed loop control system, another name, servo system, classified as a servo. The control system must be capable of following something in order with the defined the desired result will determine the present condition, some of the method of the feedback compared with the desired result. of the present conditions or obtaining the difference in error with the signal with the issuing with the correct order with the error, the signal will properly change with the existing conditions to the desired result without being in the correcting order. We have discovered the open and closed loop of the control system with the define the servo system as in the closed loop control system, and although not technically accurate with the define the open loop control system as also referred to in the Navy in many complications as a servo system, even though they lack one of the 5 basic requirements that the feedback. Operation of the basic servo system. For the following, we discuss the servo system refer to figure 2 with the view A and B with the C and C and the D with the closed loop service system, the most common type of the Navy today with the normally made with up to the electrical mechanical part that consists of basically the Synchros, the control system, the servo, the amplifier, servo motor, some form of feedback response. Figure 2.2 basic servo system closed loop. Synchro control system input with the synchro control transmitter, the control transformer, and goes into the SA. The servo amplifier, servo motor, and then the load dial, and then that from there, in between the servo motor and the load, it goes to the feedback response back to the control transformer. The show the control transmitter with the 90 degrees with the error message between the control transformer, the error signal being sent to the amplifier, the end to the motor, and the load back and into the between the motor and the load back to the control transformer. Basic servo system control transmitter at 90 degrees with the control transformer at less than 90 degrees with the error signal to the servo amplifier and servo motor to the load of the less than 90 degrees back to the counter control transformer. Alright, control transmitter 90 degrees control transformer single servo amplifier servo motor load 90 degrees. The servo control system provided with the meaning of the controlling movement of the load, which may be located with the remote space with the servo amplifier, servo motor with the parts of the system in which the power is actually developed to move with the load. As you remove the control signal with the control transformer, the relatively weak to the too weak with the drive with an electrically motor directly with the U with the A through D with the figure 2.2 with the assume with the control signal with the will initiate with the hand crank with the interconnect with the synchro transmitter with the dial and locate with the synchro transmitter with the synchro start with the control transmitter with the control transformer indicate with the position with the synchros rotors with the dial with the load indicate with the position with the load and view the detailed bolts with the control transmitter load indicate with the load with the desired position, but they'll be really cover the load with where it should be there with no ear or signal present with the servo amplifier, no power for the servo motor. Alright, if you be the rotor with the servo, the control transmitter has then moved with the hand crank with a 90 degree with an indicator that is ordered to move with the load with a 90 degree with notice with the rotor with the control transformer. Still is here with the control transformer. Now it develops a signal called the error signal with the proportional amplitude with the amount with the control transformer. Rotor is out with the corresponding with the control transmitter with the rotor with the phase with the error signal with the indicator with the direction of the control transformer. Rotor with the must move with the reduce with the error signal with the 0 with the null out with the error signal. The same with the servo amplifier with the UC with the error signal has been applied. By the servo amplifier set on the servo mode with the motor start with the drive with the direction will reduce the arrow signal with the bring with the control transformer the rotor back to the point to the corresponding in the case of the motor and turn clockwise. The mechanical linkage with the attached with the servo motor is also move with the rotor with the control transformer with the feedback with the curve of the amplitude with the arrow signal with the decree with allowing the speed in which the loading is moved with the view with the servo move with the both driven both with the load with the rotor with the control transformer. So with the control transformer is now in the corresponding with the control transmitter rotor as a result of the arrow signal to reduce the 0 null with the load stop at the new position. Note that the servo system that we move with a heavy load with a predetermined position with a simple turning hand crank with the respond with the hand crank with the servo system perform basic position of the function. Two key points with remember the less fail for the operation for the closed loop servo system. The original error with the move with the control transmitter rotor was detected with the control transformer. The reason for the control transformer is called the error detected with the servo meter in addition with the move with the load with this provided with mechanical feedback with the control transformer to reduce the error signals of the reason for the servo meter is called the error reducer. Functional servo loop. The servo system that was classified according to the function of the position velocity of the acceleration will cover the most common position velocity in detail. The position of the servo loop, the primary purpose of the position servo loop, the control of the position load with the drive with the U with the Q with the person is from the great number of the device. For example, the value of the control servo of the weapon success for the servo loop, the which just don't explain with the U with the block diagram figure G2, but in the fact of the AC position servo system and the AC position servo system and the amplitude and the phase of the AC error signal determine the amount of the direction of the load that you're given. In a DC position, the servo system, the amplitude polarity with the DC error signal respectively are U, but the determine the amount of the direction of the load will be driven. The figure 2-3 view A with the block diagram close the DC position of 0. Note that the Greek letter stigma means the assumption of the rest surrounded by the circle. Input goes into the The servo, I don't know what that. I forgot what Latin Greek thing in the amplifier motor load feedback. I believe it's the servo would be that. The assumption of the sum point of the input signal of the response signal of the feedback are summed to produce for the error signal. View B show the more in-depth illustration on the view A with the wiper arm with the rotor 1 and rotor 4. Add the midpoint with the travel to the voltage with the wiper arm with the ground with the 0 volts with the 0 volts with the also made with the connection point with the when with wiper arms resistor 1 and resistor 4, the midpoint travel the voltage with the wiper arm with ground with the 0 volt with the 0 volts will also be made with the conjunction with the between resistor 2 and 3 with the assumption point. This means that the error signal is 0 with no input signal to the amplifier out with the 0, therefore the motor shaft remain with the stationary. Figure 2-3B block diagram point position of servo and show the 45 volts positive and negative on a circuit with the adjustable resistor grounded into the input signal of the servo with a resistor 2 and 3 going into some point with the amplifier motor and load and the feedback going back to the load to the input signal. The purpose of the explanation of the image of the resistor 1 wiper arm with the mechanically move the output into the new position when the voltage between the wiper arm and the ground measure for the 10 positive volt for the further measurement of the shift show that the 0 volt between the wiper arm and the resistor 4 with the ground and the sense of the resistor 2 and 3 with are equal with the value with the positive 5 volts measured between the sum point with the ground and 5 volts with drop the cross of each of the resistor 5 volts is the sum of the point with the error signal and as shown in figure 2-4 with the view A and view B with the view C with the no error with the present voltage with at some point with the G with the cover of the network composed with the resistor 1, 2, 3, and 4 is balanced with the wiper of the resistor 1 move toward the positive 45 degrees of the network become with the unbalanced as shown in view B with the left hand side over the resistor 2 becomes 5 with the current called with the flow of the positive 45 volts with the resistor 3 and 2 to the 10 volt positive the left side of the resistor 2 because the resistor 2 and resistor 3 are equal value with the voltage drop and then will equal therefore the voltage at some point will equal positive 5 volts. Or this shows the development of the error signal. We have the 45 and the positive and negative on the resistor 1 and 0 volt point going into the input of the resistor 1. From resistor some points of the voltage is equal to 0 volts in between resistor 2 and 3. The feedback, the input goes to resistor 1, resistor 3 goes to the feedback at 45 degrees and negative 45 degrees. Okay, figure 2-4 shows the development of the error signal of the 0 volt point, resistor 1, 45 negative 45 volts, input 10 positive 10 volts, resistor 2 5 volts, and sum of the point B into the E volts of the 5 volts. Feedback signal between resistors 3 and 4. The error signal the positive negative 5 positive negative 4 volt negative 45 volts negative and negative 45 volts input signal resistor 1 10 input signal 10 volts the sum of the resistor 2 and resistor 3 and they're in between some split phase is 0 volts resistor 3 and the feedback of the negative 10 volts or the positive 5 volt error signal is fed by the amplifier. Amplified output start with the drive of the motor with the mechanical feed with the motor drive with the resistor 4 wiper arm with the 2 with the resistor 1 with the wiper to move with the wave with the shown the UC with the cup with the right hand the side with the resistor 3 together negative with the wiper 4 with the wiper start with the resistor 4 wiper travels far enough to the turn toward with the negative the cup with the right hand side with the resistor 3 to equal the voltage with the opposite polarity on the left side hand side with the resistor 2 simply stated voltage with the sum of the point with the 0 again with the motor with the will stop at the truth because of the resistor 2 and 3 with the equal magnetic value when the left hand of the side with the equal to 10 positive volts, right hand side equal to negative volts with the point of the 2 resistor become with the 0 volts at the time of the instant of the curve the output shout of the position load in the new position. Figure 2-5 show for the basic operation tickable position of the servo with the wide applique with the nave with the equipment to remember the position of the servo input order with the indicate with the position when in which for the load is to be played with the load with the figure 2-5 with the gun term with the purpose of this system and the position of the gun and by means of an order with the remote hand crank with the load is mechanically coupled through the gear train with the rotor over the control transformer. This turret position with the always accurately represent with the position of the control transformer with the rotor with the ordered single desired position for the gun term with the servo with the position of the rotor with the control transmitter within the hand crank with the corresponding side immediately with the peer with the crowd of the control transformer state. Here where the signal differs from the actual position of the gun term with the air voltage with the development of the aircraft with the control transformer, the rotor with the air voltage with the head with the control transformer, rotor with the servo amplifier. At this point with the cover into the power with the polarity phase relationship with the driver of the motor with the direction necessary to bring the full load into the desired position. Turret motor moves mechanically feedback with the control rotor with the torque with the arrangement of the which with the control transmitter with the rotor load approach with the proper position position, less and less power with the applied with the motor because of the decreasing air voltage with the car. Develop the control transformer, electrical position with the control transformer, rotor agree with the position of the control transmitter, rotor air voltage reach of zero, but the power is removed from the motor and the turret is now desired position. Alright, this is a typical position of the servo. You have your set to desired position data input with the control transmitter with the three-way windings going in the control transformer. Your data feedback, turning an actual air position desired servo amplifier air signal going to the control transformer into the servo amplifier to the driver motor, turning the load target. The actual system heavy going to determine the moment the tons of the care with the desired position for the overshot over the road with the control transformer to move with the corresponding with the control transmitter with the term of the dwell with the new air with the signal of the opposite with the layer with the original input signal with the new air signal with the cover the term with the drive back for the road with the desired position the turn makes the turns moment that once again was overshot with the marking of the system drive in the opposite of the direction again the oscillation of the load around with the desired position allowed with the unchecked with the condition knowing hunting and the result of the figure of the G6 show with the general geographically as a result Syria over travel the corresponding point with the hunting and the most with the servo electronic network known with the anti-hunt dampening of the system is used to minimize this undesirable effect will cover the anti-dampening dampening system and the deep layer later in this chapter. Alright, 2-6, over travel the corresponding points of the hunting. The angular displacement, new order position, previous position time. Velocity of the servo loop. The velocity of the servo loop, the velocity of the servo loop is based on the same principle of the rare signal to generate the position of the servo loop, but there are some operational differences, two major differences. Valve lose the loop with the velocity of the output is sensitive rather than position of the load, but when the velocity of the corresponding with the null with the position error signal is still present when the load is moving. On the top of the servo load, you put the application where the load is required with the driven with the constant B with the speed with the governed level of the air signal present with the radar antenna start tracking a telescope, the machine tool, cutting tool with the other device requiring with various speed regulation. All examples of types of the load with the servo may be you with the drive. Figure 2 step of the servo the block diagram velocity servo loop and similar with the block diagram of the position servo loop except with the velocity servo loop contained with the tachometer and the feedback down line with the tachometer is the tach is a small generator that generates the valve which is proportional to the shaft speed. Alright, figure 2-7 show the block diagram velocity of the servo. You have the 45, negative 45, the resistor 1 input signal going into rotor 2 and rotor 3 of the servo that going from the air signal of the amplifier motor loader into the feedback tach meter back to testing the rotor 3. Rotor resistor 3. In this application for the package feedback with the drive for the design produced with the 1 volt with the feedback with the 10 RPM. Let's assume with the motor with the design with the 10 RPM with the each with the volt with the rear ear signal with the figure 2-7 show with the tach with the mechanically controlled with the load with the arrangement the shaft with the tach rotates as the load rotates. The tach can be set with the sense of the speed rotation of the load, but the purpose of the explanation will assume that the load of the antenna will rotate with 30 RPMs. Initially, the wiper arm of the resistor 1 is a set of the 0 volt point mid position of the amplifier with the 0 volt to the left of the resistor 2 since the motor not turning the load but not being developed. Driven the tach output with the 0 volt with the applied with the 0 volt with the left side of resistor 3. Under these conditions, the 0 volt with the valve at some point with the motor is not driven the voltage at some point with the air signal with the wiper arm with the resistor 1 move to the negative 9 volt point. The air signal will appear for the sum of the point with the first instant with the air signal will get the sum of the point with the negative 4.5 volts to the cover of the first instant. Load tach have not started to move with and tach output with the 0 volts wiper with the resistor 1 negative 5 volts, 4.5 volts as better than the sum of the point, but then this voltage will cover the motor to start to rotate the load. After the period of time, the load at the tach meter rotating at 10 RPM with the cover of the tach and having the output with the 5 volt with the 5 volt with the tach applied with the bottom with the resistor 3 negative 5 volts. Negative 9 volts with the resistor 1 wiper applied with the top of the resistor 2 volts with at some point with the air signal with the negative 4 volt with the motor will turn with the 10 RPM with each of the volt air signal with the motor continue with the speed with the load reach with the 30 RPM with the tach output with the plus velocity 3 volts with 3 volts bottom with the resistor 3 with the negative volts with the top of the resistor 2 with the air signal at some point with the negative 3 volt with the negative 3 volts voltage required to drive the motor with the 30 RPM. Play for the system of the balance to satisfy the two condition velocity of the servo velocity of the output with the strength of the tach of the air signal with the negative 3 volts with the still present load with the continue to move with the velocity loop with the corresponding 330 RPMs. You may ask for the velocity of loop with the feedback necessary for the motor turn for the 10 RPM for each for the 1 volt with air signal will not simply with the V but the negative 3 volt with the amplifier with the wipe with the resistor through 1 but did not have the attack summing of the network. The answer for the velocity of loop with the regulator with the speed of the loading and change with the condition if the load of the figure 2 step with the rotate with the antenna with the ship antenna would tend with the slow down with the winding of that wind opposed with the movement of the speed up with the wind aided with the smooth with when the antenna show with the down with the output with the attack will decrease with the synth with the attack is connected with the load with the attack output. Decrease the air signal will increase the amplitude with the cuff of the motor with the speed up in the same way with the antenna speed up with the tag output would increase the air signal with the motor would slow down without the velocity of the loop of the compensating with the change of conditions they could not respond in the desired manner. The system shown in Figure 2 with a simplified version with the velocity of the loop, the practice of the reaction with the motor air voltage with the output with the tag would not equal the 10 RPM per volt with the 1 volt per the 10 RPM. This would compensate with the gearing between the motor and the load between the load and the tag value for the consumption network in which the resistor 2 and 3 are right equal. The equal the unequal resistor coupled the scaling factor for the compensate with the tag output with the required motor with the input. Just another way of saying the individual components of the velocity of the loop must be made to work with together with it so that they each can respond with the manner that produce the desired system results. The acceleration servo is similar with the two loop with just discovered except for the acceleration of the load sensitive rather than position of the velocity of the loop with the tag with the reverse velocity of the loop with the replay with the accelerator meter the device generates a single response with the acceleration after the feedback will do not provide with the illustration accelerator servo because of the complexity of this application of the component the type of the servo widely with the rocket emission fields are used whenever the acceleration control is required. Servo characters vary primarily with the job of the servo design to do with almost with many types of the servo, but they are job of the first servo. The servo usually have the common purpose of controlling output with the way ordered and by the input with the ideal motion of the output shaft for the position would be keep the track of the input shaft without the ideal performance that never achieved the will discover the major reason for the position show with the method attempt to approach for the ideal of the servo compared with the input signal the feedback respond with this will be the time lag between the input signal and the actual movement of the load with the also the wave of the load may be introduced with the additional time lag with the time lag with the servo decrease with the increasing gain over the servo amplifier if the gains are too high with however the servo output will tend to oscillate with the be unstable for this so you can see that they have the gain the servo limited by the stable consideration. Servo sensitivity must be considered along with its ability to reach the happy medium. Alright, time lag. To reduce the time lag gain of the servo amplifier could be increase the gain of the servo amplifier, decrease the lag time with the load, with the move after the help with the shear with the drawback from the movement of the load back with the moving after the air. It will likely cover the gain with the desired position. The overshoot with the load, attempt with the drawback with the desired position for the higher gain with the amplifier, but they cover the overshoot with the opposite of the direction. Therefore, the system they stabilize with this minimize with limited problems of overshot. This is done by damping. Damping can be done either by introducing voltage in the opposition to the signal voltage with the place of the physical restraint of the servo over the output of the actual function of the anti-hunting is reduced the amplitude of the duration of the oscillation. This makes the existing exit in the system. Every system that has one or more natural oscillating frequencies depending on the wave of the load with the design speed with the other characteristics. The degree of the damping is determined the purpose of the use of the system. When the system is overdamped, it will not be bothered with the oscillation. However, the large amount of the restraint placed on the servo presents with the additional problem. The excessive time requirements over the system and each of the synchronization figure 2A with the graphic representation showing the time relationship with regard to the degree of the damping. Alright, show the angular displacement the new ordered position at 0, the previous position under 0, and the negative frame with the under damping, and then back when it crosses over, then positive over damping when it comes to under and damping as the oscillation miles out. Under damping is a servo system other than the trade with the favorable one instantaneous response to the air, with the unfavorable trade with the erratic operation around with this point with the synchronization because of the low of the point, low amount with the restraint force with the plate with the servo somewhere with between the overdamping and the under damping the combination desirable accuracy, smoothness, and moderate short synchronizing time. Simplest form of the dampening friction dampen the application of the friction mouse share with the proportional output velocity with the amount of the friction applied to the system and the critical with the material effect with the result of the system fraction absorbs the pores of the motor, converts the power to heat, the pure friction dampen was absorbed the excess amount of the power of the system, however, two with the available system and the sum of the character of the friction dampened with the somewhat less power, log of the friction clutch and magnetic clutch. Or friction clutch damping. Your friction clutch damping. The friction clutch damping Uses friction clutch to couple the weight with the flywheel with the output with the drive of the shaft of the servo motor with the servo motor. Rotate with the clutch, couple the sum of the motion to the flywheel. The flywheel overcome with the inherent gain speed with the approach with the motor speed, with the flywheel turning and absorb with the energy by power with the servo motor. The amount of the energy stored in the flywheel determined by the speed of the velocity but cover the inherent flywheel resist any of the attempt to change with the velocity with the correspond with the point with the system. The approach with the air signal to reduce them over. Begin with the slow down and temp with the keep the output shaft with the turning with the same speed with the flywheel. Leave the sum of the energy and the shaft with the scalp with the first overshoot with to be large. The servo system drive with the pass with the point with the corresponding new air signal is developed. New air signal is over the opposite of the polarity coupled with the servo system motor drive with the opposite of the direction. Once again, with the flywheel resist the motor movement, absorb the energy with the system coupled with the large reduction of the second overshot with the solid subsequent overshot with the system. The overshot the overall effect of the dampening of the oscillation point with the corresponding reducing the synchronizing time. The motor rotation transmitted with the flywheel with the friction clutch with the inherent with the flywheel actively added with the load of the motor. Friction clutch is designed to slip with the rapid change with the direction and speed with the slipping effectively disconnect with the flywheel instantaneously and thus cover the amount with the power with the flywheel draw with the motor. Your magnetic clutch. Another type of the damp of the magnetic clutch. This type of the similar with the function with the friction clutch. Damp of the main difference between the two and the methods with a couple of the flywheel with the shaft of the servo motor. The two distinct type of the magnet of the clutch. Damp of the first sheet with the magnet flood. Feel the result of the two friction clutch blades together will produce the damping action similar to the friction clutch which we just described. The second version of the magnetic clutch is using the action of the magnetic field with the generator with the two sets of the coil with the one set with the coil with the induce for the eddy current and the end result with the rotation of the single set with the coils near the conducting surface of the flywheel. Coupling the type of the clutch is made with the interaction two magnetic field with the physical contact between the two coil eddy current type of the magnetic clutch with the office with the smoother operation for pure friction clutch with no problem wear with the cup with the friction. Summary smooth the efficiency operating over the servo system that can be only achieved with the system with the compromise recall with the earlier with the increase of the gain of the amplifier to reduce the time lag with this head drawback insulate increase the hunting of the oscillation at the point with the corresponding with the overcame with the difficulty with the friction damp with the servo the solve the problem with the hunting smooth with the servo operation to be but acted as part of the servo load with the cover with the large first overshot with the increase of the time lag. Some of the form of the damping can be used with a high amplification to obtain servo operates for the minimum time lag is needed. The answer lies with the error rate with the damping. Or your error rate damping. Error rate damping is method of damping that anticipates amount with the overshot with the form of the damping correct with the overshot introduced the voltage of the error to protect with the proportional with the rate with the train with the error signal with the correction from the voltage combined with the error signal with the proper ratio with the obtained with the desired with the servo operation.
Me and your mom will be leaving in a few minutes. Keys to my truck are on the counter if you need to go.
All right. Correction voltage combined with the error signal with the proper ratio to obtain the desired servo operation with the reduced overshooting minimum time lag of the advantage of the error ratio with the damping is foul with the maximum damping occur with the maximum rate with the chain with the error signal is present. Normally would occur with the severe loads reverse direction, same with the chain with the sense of the signal with the damping with the minimum amount with the damping with the no signal with the signal with the constant strength with is present. The error voltage of the generator with the electromagnetic device electronic networks and the equivalent of the electromechanical device widely used with the generator error rate voltage of the tachometer with the generator learn vary with the output voltage of the proportional output shaft direct velocity of the servo meter happens to the output with the voltage tachometer can be anticipated with the sudden movement and with the chain with the load. But they compensate with the electrical network for the U with the error rate damped to consider the combination with the resistor capacitor forming an RC differential integration network. You should recall that the differentiating circuit produced the output voltage with the proportion over the rate of the change of the input voltage in integrated circuits producing output proportional integral input signal. View 2.9 show the resistor capacitor integrated with it can be recognized with the output voltage being taken with the aircraft with the resistor 1 as average. The circuit developed with the transistor error signal. Small variation signal from the error detect the resistor capacitor integrated with sometime with the internal integral control circuit that will also be explained with the electrical error rate with the damping. The error detector resistor 2 and the resistor 1 with the capacitor 1 on the network in a circuit before and then running into the servo amplifier output. This show the figure 2.9 show the error stabilization network using the RC integrator. The network consists of the capacitor, two resistors connected in series with a servo amplifier with a connect with the circuit with the design to work with the concept of the error small, slowly changing error signal with the intention of the error voltage of the divide with the resistor 1, resistor 2, along with the error voltage of the apply with the capacitor 1 chart with the greater the voltage of the input with the amplifier because of the resistor circuit resistor capacitor time on the circuit that takes time with the capacitor charge with the value with the error input signal of the but in large time with the charge time of the capacitor 1 the circuit is not responding instantaneously with the rapid chain with the error signal. What means for the error all error signals will be integrated with the smooth out load will be responded with quickly with the inherent load with the reduce the system with the damping. The capacitor may not respond with instantaneously air signal with the cover of the damping amplitude over the action stabilized with the servos is the new velocity tailoring of the stabilization network through the proper selection of the resistor capacitor of the component with the system performance requirements with the type of the load with the not driven and undesirable load with the performance character that can be minimized. And the various compensation networks that you will encounter with depending on the design of the individual servo system will be covered the associated system technical manual and some of the key with the understanding of the component, the network, compensating with the network, real life of the components are, and truth in the capacitor does not have time to trouble the discharge, respond with large and rapid fluctuation. The frequency respond with the frequency response over the range of the frequency in which the system is able to respond into the movement of the character of the system chosen by the designer to so the system will be able to respond wherever the frequency expected with the presence of the input signal of the particular application. Your oscillating input signal, as we first consider with the input order, servo being with a sudden with the put with the fixed desired value with the servo that gave the orderly slow with the increase of the desired value, actual with the input order with the servo given the application that may accelerate with the start and stop oscillation about fixed point what it will need with the consider application servo while the order oscillates with the order oscillation for the load undesirable with the order positive oscillates with the load may oscillate within the same manner. Let's assume the oscillation input signal order is applied with the servo. The load will behave in several ways, but it ideally will respond with the perfect exchange within the order actual amplitude in favor of the load. But different with the order figure 210 we noted above the frequency response of the system normally designed and load is responded to the order. Show the position, order, and the time, and then show that your low and high, your frequency responses, position, time, order, load may be oscillating in phase different from the order. Then you have your position, time, frequency, response, load, mag oscillation at amplitude different from order. A servo may follow the order and amplitude different, favor the may follow the order and favor the different amplitude with the may different with the both of the phase of the amplitude with the band paths over the frequency servos if the servo applied with the noise signal with the ride with the from the system with the desired electrical signal with these noise signals cover the roughness servos if it must be eliminated to obtain the smooth servo operation of the by examining the different signal of the servos is determined with the frequency relay with the movement of the load, which one with the noise sources with the static motor harmonics mechanic resonances. Filter signal within be with the shunt with some of the unwanted frequencies away from the amplifier, allow with the frequency reps with the load movement into the engine of the amplifier. This can be also accomplished designing the bandwidth of the servo amplifier to accept the range of the frequency represented with the servo system, rejected all the others and smooth the servo response, but as a drawback to reduce the amplifier gain, they reduce the amplifier bandwidth and another compromise in achieving the output optimum servo operation. Are your servo components in circle within section will discover the component that make up the typical servo system. We cannot cover all the possible servo applications here with the various fashion with the servos of the configuration circulating component that discover the following page with the most commonly with the U with the representative of the broad view with the system U with the navy today with the monad attempt the two but units to any with the rigid classification system will mention some of the most common terms used with the manufacturer navy to classify the device for the familiarize itself with the wide variety with the nomenclatures. We will cover the much for the electronic application discussion theory with the unit that may want to review with the applicable to needs module with the other source of the big four. During this discussion, we'll find the much more match material than necessary to understand the subject contained within the basic theory of electricity and electronics. Position sensor. Position sensor divided with the chain with the mechanical position of the voltage with the representing the position of the output of the point sensor that can be either AC or DC, both with the many different kinds of the point sensor with the last chapter to learn with the control transmitter, synchronizing the device with the representative of the position with the rotor of the voltage with the state of the control transmitter, U with the position sensor for the servo system earlier in this chapter of the device can be U with the position sensor for the tipple. The pentameter is on one of the device the pentameter with the position sensor for the generally usually only with the input and output servo the mechanism limited most for the character out of the high accuracy small side with the may have the either DC IAC output voltage with the disadvantage include limited motion with the light problem the result of the wear of the out of the bar of the pentameter wire also the voltage output of the pentameter change with the discrete step of the brush moves over the wire to wire with the further distance the further disadvantage of the servo of the pentameter with the high drive with the torque with the required to rotate the wiper contact. A pentameter is one of the most simplest means of converting mechanical position information into the proportional voltage schematic representation. Pentameter is shown figure 211. Show that the in voltage going to the resistor. The pentameter is also hitting the resistor on the ground and from the end in between the and the out of the load resistor down. A pentameter is a variable voltage divider with output voltage with the percentage input with the voltage with the amount of output voltage proportional position wiper voltage wiper relatively low with the end of the example the resistant ground wiper of 50% of the total output voltage same with the body with 50% of the total voltage across the pentameter. The basic closed out loop servo system with the balance but pentameter and position sensor is shown in figure 212. All right, 212 show the balanced pentameter with an in-position sensing. Supply voltage going through circuit with resistor, resistor 1 and resistor 2 on a circuit with a supplied voltage. This is the input shaft that hits resistor 1 and into the servo amplifier with the motor, and then the output shaft is running on a mechanical response for the servo amplifier motor to the load. The command input shaft with the mechanically linked with the resistor 1 with the load with the mechanically linked with the resistor 2. The supply voltage applied with the cross with the old pentameter. The system designed with the input and output shaft with the same angular position with the voltage with the new pentameter with the equal with the error voltage with felt amplifier input with the input shaft with the moving with the wiper contact with the resistor 1 error voltage with the applied with the servo amplifier error voltage with the difference between the voltage with the wiper contact resistor 1 resistor 2 output with the amplifier coupled with the motor to rotate load with the wiper contact resistor 2 continue with the both of the voltages are equal the voltages are equal the motor stop with the ineffective position with the output shaft that has been sent to the balance pentameter. All right, 3. The error detectors. Electrical error detectors may either be AC or DC device depending on the requirements for the servos. If the device for the error detector must compare with the two signals to produce an error with the signal of the FA of the amplitude will indicate the direction of the amplitude with the control respectively with the necessary for the corresponding to the DC's device. Different the polarity of the output error signal with the direction for the necessary correction will discover the following paragraphs of various in device for the commonly used with the servo system. Summing network. Summing networks was when mentioned earlier with the error detector with the servo applications where the servo output with the proportional algebraic sum of the two with more input, but the typical circuit is shown in figure 213. Summing the network, you have voltage 1, voltage 2, voltage frequency, and voltage 1 goes to resistor 1, and voltage 2 goes to resistor 2, voltage frequency radio, resistor frequency, and the summing of the network goes to servo amplifier, motor, output shaft, back to the tachometer, with the tachometer tact, goes to the electrical response of the radio frequency, the servo amplifier, motor, and output shaft. Error voltage is equal to voltage 1 plus voltage 1 equal to the voltage frequency. As this case, pentameter with the network, even the AC, the DC voltage with the phase, with the polarity, with the input voltage, during the whether the signals are additive, with the subtractive, with the become with the figure, to the refer to the figure 213 with the two input with the signal with the voltage 1, voltage 2 with the apply with the network will provide the error voltage with the output, proportional algebraic sum of the two signal with the servo meter, the drive with the load with the H for the tachometer supply with the feedback with the voltage of the resistor frequency, you know, with the resistor frequency null for the error signal within some of the installations. Servo Motors may position with the wiper arm with the piezometer, but instead of the drive and the tachometer to supply the feedback voltage. All right, your basic E-transformer, typical magnet, U with the layer detector of the system in which the load is not able to move with a large angle. In the basically error voltage the E-transformer, shown in figure 214, the AC voltage is applied with the primary coil tube located with the center line with laminated with the E-shaped core with the two secondary coil with the 1 and 3 with the and or wound with the serial pole for the outer poles of the magnet coupled with between the primary of the coil tube with the two secondaries vary with the position of the armature mechanically physically move to the left to the right with the magnetic circuit with the mechanical linkage of the lobe with the chain with the reluctancy between either of the pole and the armature. Alright, this shows the armature basic E-transformer. The three windings show the armature move it over the lines, basic kind of switch, almost like a hydraulic piston. You find in a steam engine, two-chamber, slides over the top. When the armature is located with the center of the E-shaped core, with the shown with the figure 2 with the equal of the opposite voltage with the use of the secondary coil, with the difference between the these zero with us, the voltage of the output terminal is also 0. But the armature move with the state of the light with the voltage with the new for the coil, the increase with the voltage with the new for the coil with the read to degree with the 2 volts for the unequal, the difference with the no longer with the 0 with the new voltage with the result of the output terminal with the amplitude of the voltage directly proportional with the distance armature with the has been moved with the center position phase of the output voltage with the relative of the AC or primary control with the direction of the load move with this correcting error. The basic E-transformer directs for the movement of the armature. There is one axis of the E. It's either horizontal or vertical, depending upon the way of the wing unit is moved. It detects the movement of both the horizontal and vertical after the cross E-transformer is used. If placed the E transformer the right angle with each other, replace the armature bar armature with the dome-shaped one that you have the basic configuration. Well, know that across the E transformer, pick up the most applicative dome-shaped armatures are attached to the gyro. The core of the assembly is fixed with a gimbal, which is the servo load. Show the horizontal core assembly, the primary winding, vertical coil, horizontal coil, reluctant dome armature, vertical coil. Cross E transformer. All right, so you got your primary windings on the corner. It's like a cross running in vertical coil, horizontal coil. The cross E transformer assemble consists of the flat leg with a pole with each leg with its incapable black coil with the coil around with the center leg with the primary winding and primary which excite with the alternating voltage with the remaining four with the coil with the secondary with the furthest view. You can see how the name of the cross E with the reluctant dome of the armature with the move with the left center with the more flux line with the left leg with the primary coil with the voltage and the left secondary with the right leg with the clear flux with the linkage with the center coil with therefore the voltage and with the right coil will be less than in the left coil therefore there will not net the voltage out of the pickup of the phase of the output will be in and out with the larger volt with the dome and the move with the right with the output condition would exist. From this brief description you can see that the cross E transformer works with the same fundamental principles out of the basic type that we described earlier with the major difference between the two is in the shape of the number of the secondaries and fact of the armature and universal movement. Control transformer. Commonly used with the magnetic area to check with the synchro control transformer when used with the control device servo system the recall of the cover of the control transformer operates for the depth of the chapter 1 over this module with the scope of the application for the servo system earlier in the chapter the active area to check with the control transformer compared with the input signal with the improv of the palm of the shape with the angular position of the rotor actual position with the lobe of the output of the electrical error signal is taken from the rotor with the difference between the air order position and the actual position of the load. The primary advantage of the control transformer over the top of the air detector the limited rotation angle and the both of the input and output synchro control transformer the rotate with the unlimited angle. The disadvantage of the output signal supply with the servo amplifiers all way for the air signal must be demodulated if to be used with a DC servo. Your rate generator tachometer was mentioned earlier. The tachometer with the velocity servo system has the heart of the feedback with the loop of the U with the descent for the speed, velocity of the low. The tachometer sometimes referred to as the rate generator. Whenever the name of the small AC/DC generator developed the output volt with the proportional within the RPM of the phase of the polarity depending on the rotary direction of the rotation of the DC rate with the generator, usually a permanent magnetic field with excitation. The AC rate generator field is excited back with a constant AC supply, either in this case with the rotary tachometer mechanically connected directly with indirectly to the lobe. The AC rate generator. The one type of the AC rate generator which is widely the path of the drag coupled to the tachometer generator of the figure shown in 216 and show the two-stator winding 90 part with aluminum copper rotor with the rotor rotate with the used around the stationary the soft iron magnetic core on stator winding with the inner type of the reference for the AC source with the other stator winding is general output with the secondary winding with the voltage supply with the primary winding produced with the magnetic field with the right angle with the secondary with the winding with the rotor stationary with the shown view A with the rotor is turn of the mechanical link of the load that stores the magnetic field is no longer 90 electrical degrees from the secondary windings of the flux line with the secondary winding with the 8 volts of the M and due to the output winding is shown with the view B with the C. The magnetic field will be distorted and determined in the speed of the rotor. Therefore, the magnitude voltage with the induced for the secondary winding is proportional to the rotor's velocity of speed. All right, this shows view A show the windings of the AC supply around the primary reference coil of the undistorted flux aluminum copper cup rotor stationary iron core zero your secondary output stator coil zero output flux distortion by rotation of rotor primary and secondary coil. This was the and then this one would be primary and secondary coil. We're turning the wheel. That's your AC drag cup rate generator. Or the direction of magnetic field of the distortion determine the direction of the rotor. Most of the rotor is turned with the one direction of the line flux will cover the secondary one with the one direction of the rotor. Motion with the reserve the line flux will cover the secondary one with the opposite direction. And therefore, the phase of the voltage with the induced of the secondary winding measured with respect to the phase of the supply voltage will determine the direction of the rotor's motion. The phase relationship with the shown view B and C with the output winding with the frequency tachometer generator output voltage with the same frequency of the reference volt with the output voltage generator with the primary and alternating flux field of cutting of the secondary winding. Therefore, the output voltage may have the same frequency as the supply voltage. The other type of the AC tachometer generator has a scroll cage rotor. Otherwise, the construction and principal operations are identical to the drag cup type. The DC rate generator. The DC rate generator uses the same principle of magnetic coupling with the AC rate generator. The DC rate generator, however, it has a steady, non-fluctuating primary magnetic field. The magnetic field is usually supplied with a permanent magnetic amount of the voltage you can do for the rotor winding with the proportional with the number of the magnetic flow lines cut. The polarity of the output voltage will determine the direction of the rotor cut with the lines with the magnetic flux. The physical makeup of the theory of the operation for the DC rate generator is very similar with the DC generator. The Neets module 5 of the introduction to the generator's mode. The only major difference for the side of the primary mover of the attack of the mesh is smaller than the length of mechanical the servo motor load instead of to the primary mover. Tachometer generators are used in servo systems to supply the velocity damping signal and are sometimes mounted within the same housing with the servo emitter modulators in the servo system. Because of the problems associated with the DC amplifier, so with the drift of the where output vary with the new variation in the input signal of the AC amplifier must be widely used with the servo application for the creativity need of the device to convert the DC error signal to the AC input with the servo amplifier so for the device to refer to the modulator modulating technique vary with a different type of electronic equipment. Thus, the modulator servo system performs a completely different function than the component. All right, thank you. Bye. The modulator servo system performs with a completely different function with the counterparts in the radar communication system. The servo modulator converts the DC error signal to the AC error signal with the modulator. You have the two input that produce the AC error signal. One input of the DC error signal is the example of the input of the pentameter, the other input of the AC reverse voltage with some other sort of as the SWP AC supply. Supply system. The AC output of the error signal must contain the same control information that contained within the original DC error signal but done with the following manner. The phase between the AC output of the receiver references the signal of the difference for the polarity of the DC input signal. The phase of the AC output of the indicator the direction of the error, the direction of the load movement, the amplitude of the AC output of the proportional amplitude of the DC input signal indicates the amount of the error signal, the speed, the angular displacement of the load. These relations with the phase, the amplitude must be maintained with the ensure the load will move with the desired amount with the proper speed with the right direction. Typical modulator, you will see with the servo system the crystal diode modulator with the following paragraph with a brief explanation of the modulator works. Your crystal diode modulator. The crystal diode modulator, figure 217, consists of the diode bridge of the transformer network, and the AC refers to the voltage of the applied with the transformer 1, diodes control rectifier 2 and 3, conducting the more during the negative half cycle. Inversely, the diodes conductor diode 1 and 4 conduct the positive half-life cycle the diodes will conduct. Under these conditions, become with a 180 degrees phase reversal across the transformer when the current file with the direct positive of the negative half cycle will represent with the dotted arrows, solid lines, solid arrows, dotted arrows, and solid arrows, respectively. Some of the positive of the DC arrow signal is supplied with the negative going AC voltage input halfway cycle with the primary transformer 1 current will flow with the ground upper half of the primary winding with the transformer 2 through the diode control rectifier 2 and through the upper half of the secondary winding with the transformer 1. The DC power to produce the positive going voltage of the air that will cross the secondary transformer 1, the first half of the cycle of the output signal. REC reference with the transformer 1 iron cores tapped center tap with the DC error signal positive negative and control rectifier circuit with a resistor going from the transformer 1 control rectifier circuit and then 4 control rectifier diodes. And between control rectifier and the connected to the control rectifier diodes four-way circuit is a second tap transformer, center tap transformer, AC error signal to the AC servo amplifier. Positive going again with the AC input with the voltage for the half cycle of the current will flow with the ground through the lower half of the primary transformer 2 through the diode with control rectifier 4 through the transformer 1, the DC error signal single sort of produce the negative going voltage with the error signal with the aircraft with the secondary transformer 2 with the complying with the cycle with the AC input in the reverse. Reference of the node for the error signal is 180 degrees alpha with the reference signal with the negative DC error signal that was applied with the modulator but under the same condition as the reference signal with the current flow through the circuit will be reversed. Keep in mind that occur for example when the load approaches the desired position in the opposite direction the circuit will work with either positive negative DC input signal but only one condition that will exist at any given time with the negative DC error amplified with the current will flow with the DC error signal will source for the dials the control rectifier 1 3 and 1 with different half cycle with the AC reference to the ground with the cover the AC voltage with the produce the cover with the secondary transformer 2 with the same name of the previous described in the positive DC error and signal input. The only difference of the current will flow with the upper and half, the lower half of the transformer 2 with the different with the direction of the actual over the ground with the call to the output with the phase of the AC reference signal. And some of the modulator produce with the output with the either favor the 180 degrees out favor the A reference signal with depending on the multiplier with the DC input signal. The amplitude of the output will be proportional to the DC input signal up amplitude with the frequency AC reference voltage. Your demodulators in the servo system, as you know, the servo system, both of the AC and the DC servo maybe there's the motor depending on the requirement of the system will require to move the light load with the constant speed with the U of the AC motor, the system of the requirement of the heavy load with the wide speed range of the use of the DC motor with the requirements of the some system called the DC motor, other DC's device of the air signal with the servo system must be with the converter with the DC air signal with the being fed with the DC servo amplifier conversion is made with the circuit the demodulator. As the modulator demodulator maintains same relationship between input and output signal, just like the modulator demodulator's output of the amplitude with the proportional to its input with the signal of the output polarity determined in the favor of the input signal. The relationship they have to the modulator you start with the necessary with the new air signal that will control the servo emitter with the desired manner. Alright, your diode demodulator. One example of the servo demodulator with the diode demodulator, sometimes called the phase detector, shown in figure 218. The issue of the circuit is that the servo system we cover that not only converts AC to DC, but it also is able to distinguish the phase of the AC by comparing the reference of voltage with the do not confuse the circuit and other phase detector with the sort of the U of the radar or communicate with the system of the demodulator phase detector to distinguish the signal to either then in phase with 180 degrees out of phase. For this reason, the circuit is used with the servo system with the AC output with the air detector for the control transformer either in the favor of the reference signal or 180 degrees out of phase. Whether the top of the air to active with the U of the servo system, the reference volt of the air with the detector with the demodulator, and in the favor of each of the demodulator to do its job. Figure 218 diode demodulator, AC air signal the input with the transformer 1 with the tap, center tap, transformer, AC signal input, transformer 2, 3 wound iron core with a center tap transformer 2 with a reference voltage of the 2 solid iron core. On the split plate, it runs that in the center. It goes, so you got a split page between control, would be one side control current rectifier 1, transformer 1, tap center. Control rectifier 1, transformer 1, resistor 1, capacitor 1, and control rectifier resistor 2, capacitor 2, grounded DC air input output signal DC servo amplifier. As shown in figure 218, the anode of the two diodes supplied with the same reference voltage with no AC air input signal with the transformer 2 with the equivalent of the both diode with the conduct with the equally on positive half for the reference voltage with the voltage drop across resistor 1. And one and the resistor are equal to the result of the two input terminals being the sum potential. Therefore, the output voltage is 0 with the positive with the half cycle during the negative half cycle with the negative voltage felt when the anodes of both diodes. But diodes are cut off the area, cut off the 0 potential valve across the output terminal of the circuit to remain with the condition the air signal they supply with the make with the work of the circuit, the work with the control rectifier will with the conduct with the input signal, then pay with the reference voltage only with the positive half of the cycle with the control rectifier 2 will remain with the cutoff to be left to pay with the relationship between the AC air signal and the reference voltage of the chain with the 180 degree with the cutoff of the control rectifier 1 diode with the cutoff of the chain with the could be brought through an error detected with the servo system sensing the chain with the direction of the load with the effect will have the one diode circuit with the one direction of the rotation. Assume that the AC air signal is supplied with the transformer 2 with the make with the anode with the control rectifier positive with the anode with the control rectifier negative at the same time. The reference voltage of the anode with the control rectifier 1 and 2 with the design the positive with the half cycle with the these conditions control rectifier 1 with the control rectifier 2 with the cutoff of the positive voltage will develop the cutoff of the resistor and felt output terminals during the negative half of the cycle with the negative voltage will be felt with the anode's control rectifier 1 and 2 will be the cut off of them the output circle with the one with the apply with the circuit cycle reference signal with the filter pulsating DC voltage as long as the input of the reference signal in favor of the circuit acts as a halfway rectifier filter network. As mentioned earlier, with the circuit will also respond with a 180 degree phase of the reversal of the input with the reference signal for the instant of the air signal applied with the transformer 2 with 180 degrees out of phase of the reference signal. The control rectifier 2 with the control rectifier 1 cuts off the causing output voltage of the chain with the polarity of the way may encounter with the variation of the diode pose detector and how they all depend with the same principle of the operation. But quickly, summary of the demodulator converted with the AC input signal with the DC air signal, the polarity of the DC air or signal was determined by the phase relationship between the AC air signal input, AC air input signal with the reference signal, the amplitude of the desired air in signal with the directly proportional to the magnitude of the AC input signal. Your servo amplifier. The servo amplifier previously discussed where you use the servo system to amplify the either AC or DC air signal with simply amplitude with the drive of the servo meter. The amplifiers have the air. Same with the amplifier with the principal servo. The Neets module 9. Neets module 8. Introduction to the amplifier. The basic amplifier chosen from the servo system must have the following characteristics. Flat gain versus frequency response over the broadband with frequency. Interest in the main phase shift with the chain with the input signal with the video phase in desired button. Small amount with the phase shift acceptable and constant low output independent of the low noise level. Upon this point with the discussion servo with the amplifier with the directly connected with the motor with the drove with the load with the servo amplifier. Also you with the simplifier with the itself with the amplifier with the air signal with the forward with the example the signal with the D module they filled with the network with the may require the additional amplification to maintain signal strength with the K with the amplifier. You with the feed large drive motor to move with the large load basic electronic amplifier presented earlier in the training series is not adequate to do the job. The type of the work was done by large power with the amplifier device such as the amplitude generator Needs module 5 introduction generator motors and magnetic amplifier, which will be discussed later in this chapter. AC servo motor for the large AC motor is too efficient for the servo meter to move with the large load with the AC motor draws successfully with non-power with the difficulty cool with the hands AC servo meters are used with the primary to move with the light load, but the most AC servo meters two phase for the split phase and induction with fundamentally with the motor for the constant speed of the device, although the speeds can be varied with the limits for the varying amplitude voltage one over the motor with the stator one with the load may become heavy with the worst DC servo motor used. Or your DC servo motor with the control character with the servo motor with the superior with those the AC servo motor with the DC servo motor with control with the heavy load with the variable speed with the DC servo motor is either permanent magnet with the type of the U with the light load with the shunt field type of the U with the heavy load with the direction with the speed with the DC motor rotation is determined armature current with the increase of the armature with the current will increase with the motor speed with the reversal motor armature for the current with the train with the motor direction rotation move over the explanation for the AC DC with the beginning give them in each module 5 of the introduction generators motors. Alright, synchronizing character of it. Explain with the chapter 1, you with the multi-speed with synchronizing transmission system, keep the accuracy with the data, the transmission accuracy with the servo system, dependent on part with the accuracy with the input fed with the Synchros system, for example, the data dual speed, the synchronous system operation with the conjunction servo system over the two control transformer, the one in course, one in 5, with the define with the quantity with the accuracy with the done with the B feeding out with the core side, and servo amplifier with the system and far out with the corresponding shifting over the output with the define with the control transformer with the system within 2 to 3 degrees with the synchronization circuit will perform this job with the known with the synchronizing synchronizing network, also called crossover switching network, comes in for the whole hour with the power with the servo overload with the order position within the switch of the either core signal with the fine signal with the core with the signal and select with the circuit. Input the amplifier with selection with the base on the side over the air signal with the circuit receives under the core signal with the predominant factor for the selection essentially in the measure for the servo output position throughout the limited motion with the core signal drive the system into a proper synchronization with the fine signal with the shift into the control. Your semiconductor diode synchronization network. The semiconductor diode synchronizing network is fairly common and typical with the type of the U with the servo system. Let's take a look at the circuit is shown this technique with figure 219 of the illustrated. The circuit is following the explanation will assume the system in the far out with the corresponding more than 30 degrees at the time of the corresponding signal with a larger amplitude with the condition of the control rectifier 3, 4, and 5, and 6. And forward bias, depending on the polarity input signal, will cover the current to flow with the resistor 1 of the voltage developed and the resistor 1 felt with the one leg of the sum of the network with large amplitude fine signal cannot be presented by a similar network because of the control rectifier 1 and 2 with the design limited to fine amplitude, small value of the condition present with the same summing network to the core with the signal maintained with the control device drive the load toward corresponding. This shows the core signal going through a four-way control rectifier 3, 4, 5, and 6 with a resistor 1 to the ground and summing network and into the summing network. The other signal into the signal summing network is a fine signal with the resistor 2 with its own takes off on its own series to an additional series of the control rectifier 1 and 2 grounded. Then it runs into the summing network to the amplifier to servo motor when the load is 3 degrees for the corresponding core signal, even no longer than large enough to forward with the base for the core diode with the network. The effect with some of the large impediment with the cross with the diode network, which drop of the modes of the core signal with the practical no core signal with the voltage with the felt with the cross resistor 1 with leg of the summing network with on the other hand fine signal was all small time. Since the load with the close of the corresponding small fine signal with the effect with the control rectifier controls rectifier 2. Therefore, the small fine signal impressed with the cross of the summing the network with the fine signal being only signal felt would add the summing the network of the take control drive with load with the exact point over the corresponding. There are various types of synchronizing circuit for even the servo system. Some of the applications for the electronic tubes, relays, different types of the semiconductor types, diodes. There are specific types that you will encounter into the servo equipment to explain detail of the equipment and technical manual. Magnetic amplifier. As we stated earlier with the chapter, various types of the servo amplifier, you with the drive of the servo motor with the amplifier required to produce a large amount of the power. Like conventional electronic amplifier becomes less efficient with some other type of the following. The brief discussion the typical magnetic amplifier servo system, large amount of the power is required to move heavily if in load, heavy load. If you need the refresher memory, there are three magnetic amplifiers referred to module 8 with the training and then the series of the introduction amplifiers. Magnetic amplifiers in servo figure 220 for the illustrate of the magnetic amplifier being used at the output stage of the servo amplifier. Show the DC bi with the DC arrow signal with the two induction coil the L1 L2 running into center tap of transformer 1 AC reference servo meter winding 1 and winding 2 capacitor on winding 2. The output servo amplifier is connected with the motor winding is controlled by the winding 1, other winding with the uncontrolled winding 2 with the connected with the AC force 0 with the capacitor provided with the required 90 degrees phase with the necessary with the cause of the motor rotation the phase with the relation of the current through the two windings to determine the direction of the rotation of the servo motor. The magnetic amplifier consists of the transformer 1, the two status will react with the inductor 1, inductor 2, each of the three windings with the key point with the operation of the circuit live with the fact with the air circuit with the winding with the connected with the series output with the winding the area series aiding. With the circuit quiescent state with no input with the DC bias voltage with the coil with the DC bias with the current tube equally partially saturate both in reactors, the inductor 1 and inductor 2 reactance of the inductor 1 and inductor 2 now being equal to the result of the canceling current through the winding ones of the servo motor while only one input with the promoter remains in its rest. Now let's apply with the arrow signal winding the inductor 2 and the saturation inductor 1, the driving forth the partial and saturation with the cover of the arrow winding with a series of opposition result of the arrow signal aiding with the basic current with the reactor of the inductor 2, the tangle with the current of the basis current of the reactor inductor 1, the reactive with the inductor 2, reduce the cause of the increase of the current through the inductor 2 with the circuitry with the other case with the inductor 1, reverse if and true with the current decrease and balance of the inductor 1 and inductor 2 circuit result in the current flowing with the winding 1, save with the left of the right with the cover of the motor to turn, reverse the polarity arrow signal the cover the direction of the motor rotation of the chain with the in this and the down with the saturating reactor with the inductor 1, then instead of the reactor 2 with the cover the corrector with the rack current to reverse the direction over the winding 1 with the previous discussion AC motor was driven the output signal with the magnetic amplifier DC motor is required to do servo to move the heavy load as the AC output magnetic amplifier must be rectified. No, all the components that have been described into the unit servo system and in general servo system made in other electronic and electrical application. The theory of the three components have been discussed here and the other module of the Navy electronic and electronic training theory that if you have the desire or need any depth study of these components for the excellent references, electric installation maintenance book, the Navy C 0967 LP 0001 0130 Synchro and Servo subject with electrical installation maintenance books Navy C 0967 LP 000120 for basic component servo system. The reference should be available to the technical library of your ships or stations. Your multiple loop servo systems. Now that we have gone through the various servo loop and component, let's continue with our discovery of the realistic application for the servo system. Very seldom with the fine application for the one type of the servo loop is useful. It is usually several loop combined with the use of various type of the relay switch of the main component of the complex systems over the cover that work together by switching them in and out of the necessary. Figure 221 illustrates the particular application for the multiple loop servo system. You should be able to recognize the different loop component that make of the system. Nothing is real new in the system. We'll discuss the loops and component of the earlier in this chapter. Alright, mechanical input going in control transformer, transmitter and control transmitter, two control transmitters, and the synchro control system with the two into the two control transformer rectifiers. These this sort of in the synchronizing network you have, and then you have an electrical input of the going into the capacitor, I forget what the parallel lines mean, but you have a voltage DC going to a resistor, mechanical output, modulator, summing network, servo amplifier, demodulator, pushing pull amplifier, magnetic amplifier motor, so summing network going into, and then the tachometer load and back to synchronize the control system. Alright, the full line with open loop configuration, open closed loop configuration, open loop configuration, closed loop configuration, and the 3 dotted lines are mechanical linkages. As shown in real condition, the system is configured with a normal state with a closed loop with the position servo indicated with a heavy dark line with the figure the alternating configuration position with the load system with the issue with the penalty with the energy with the relay with the K2 with the switching. The system with the open loop configuration same time with the de-energization K32 that is 1-3 open with the turbo brake with the closed loop open loop shown with the medium density line with the figure with this loop. It is not accurate with the closed loop because the operator must intervene with the turning the shaft of the pentameter back to the 0 voltage position, stop with the load with the desired position, top of the circle that could be with the maintenance percent with the position low with the easy access for the assessment. Equipment such as an antenna ground mount with the open load of the loop can also function with the basic velocity loop with the simply not returning the pentameter with the 0 position result of the constant error signal at the beginning with the present with the wipe with the error with the pentameter with the condition load with the continuing with the drive with the some speed rate with determine the components in the loop. Alright, the last loop we can consider with is called loop velocity servo indicated with the defined density of the line. The loop is a switch with the operation and energy of the K1 with the note that there are 2 input of the summing network K1 and energy of the electrical input through the contact with the 2 and 4 feedback from the through the contacts 1 through the 2 7. It was compared with the summing network. The difference of the U of the arrow signal is to drive the load with the state with the equilibrium reach and the circle within load will be moving the desired velocity.